I think it was Winston Churchill at some stage said that people who do not learn from history are doomed to repeat it. And I've been trying to learn from history. That means learn what people did wrong before and trying to do it better now. And that is what all this is about. On the 21st of June 1948, a tiny computer called the Baby was the first electronic digital stored program computer ever to do anything. And from then, things happened very, very quickly. The first Norwegian computer started doing useful work in the year 5 after Baby. It was phased out about the year 8 after Baby. So when I got into the picture in 1957, this first computer, people were then discussing how to move it over to the Technical Museum, less than 10 years old. So I got onto this computer. It was standing there. The people who had used it had moved on to better computers. And I was given the opportunity to learn how to program by sitting on its console, pushing the buttons, and see what happens.
You need to move your...
Yeah. Oh, it's fallen off, has it? Like my glasses. I see, that's better, isn't it? Even I can hear what I'm saying now. The programs are made in these first years. I think I would characterize as being extreme programming. What I did was I got some idea, or somebody came to me and asked for help for something. I had a vague idea of something this computer could do, and I started writing code. And then I got that code into the computer. I was sitting for hours on the console, looking at all the lights. If one light on was a 1, if it was off it was a 0. There was a switch so I could actually change it. So I could work directly into the hardware, which was fine because I was an electrical engineer, so I knew about that anyway. The trouble was that the programs I wrote had one thing in common. If I made a small, harmless change to the program down in one corner, something up there crashed. It was just one tangle, everything depended on everything else. So that made me coin my first rule of programming. Any method that can prevent the programmer from writing code is a good method. Think first and work afterward. Order a method into the work. Why do I say all this? Because, of course, this was in late 50s, 60 years ago, something like that. And, of course, it's not like that anymore, is it? I mean, we are maturing. This was in the Stone Age. Or are we learning? I started my current project when I retired. I called it Baby UML. Somewhat whimsical about this baby because I was sort of having a vague idea in my mind. The first Baby was the first digital real computer. I was working on the first object computer. If you challenge me, I say, no, that's not what it means. What it means is it's a very small system I'm talking about. After all, there was a workforce of one very old man, and that was all. So it had to be small. But one of the things I thought also that I could learn from UML. That's why it was called Baby UML. And then I had to understand a bit of UML. And the UML specification is 600 pages, something like that. 300 pages about the static part, 300 pages about the dynamic part. I just did this static part, and I thought, well, the specification is full of tiny class diagrams. giving snapshots of classes, class hierarchies, associations, and so on. So I just made a composite class diagram with just the inheritance relationships. And to do that, of course, I needed a program to help me to draw it. And I chose the Argo UML, which is a open source collaborative effort. Lots and lots of people are spending their spare time submitting code for that. So what I did, and I'm not going to go through this in detail, I could put up rectangle boxes representing classes. I could then put attributes into those classes, and I could select the type of those attributes from a menu. Works fine. Then, of course, I had to draw all these lines, and some of them are some areas are quite complex with lots of line crossing and things, and I got into trouble. Argo UML wasn't good at that. So I reported a bug report, and wonderful. Next release, I could draw the lines properly. I could add new classes. I could add new attributes, but I couldn't type them. The menu thing with selecting the type of an attribute had broken since the last one. I was like, isn't there something called déjà vu? Have we experienced this before? They fixed this thing and broke that thing. 40 years after I learned about system. Anyway, I'm not blaming the programmers. The people who are contributing to Argo UML, I'm not talking them down. They're doing a wonderful job, but they haven't got a chance. There's no way they can produce a proper system. Anybody got a book on your shelf by Gamma and people affectionately known as a Gang of Four, Design Patterns, a white thing book? I've got one on them. It's a very good book. I finally, not so very long ago, I started reading the introduction. I mean, I never read the introduction. And it said this, which I thought was absolutely astounding. An object-oriented program's runtime structure often bears little resemblance to its code structure. The code structure is frozen at compile time. It consists of classes in fixed inheritance relationships. I would add all the first 300 pages of the UML standard, packages and whatnot. The runtime structure consists of rapidly changing networks of communicating objects. It is clear that code won't reveal everything about how a system will work. But how is there hope for a group of distributed people that, if they meet at all, it's very rarely, they communicate through a narrow channel called email. They submit some code, somebody else submits some code sort of close to it, and they can't understand what the other guy's code is doing. I mean, what are we thinking of? Why haven't people stood up and said, we can't accept this? We've got to do something about it. So that's what I've been doing. We have got to have code that reveals what the system is doing at runtime. It's runtime that a program gains any value. It's only when it's doing useful work. And we're sitting there writing code that's more or less unrelated to what's happening at runtime. I mean, what are we thinking of? So that's the theme of today. And I'm trying to learn from, I'm taking a chance here actually, because I'm trying to learn from history, which means that I have to pick up some history, and I'll try not to say, oh, those were wonderful old days, weren't they? I try not to say that, and try and learn from what we learned in the 60s actually, because in the 60s we learned how to write programs. In the 70s, we got onto object, and we haven't done it. We haven't been able to write proper programs since. So that's why I want to spend a little time on the sort of the highlights of what I think were important we did right in the 60s. I will not mention at all what we did wrong, because that's not part of the story. Then I'll spend a little time about what's currently called object orientation, but it's actually class orientation. Java is not object oriented. Simula was not object oriented. Actually, that was my mistake. I was learning Simula. Simula was developed across the yard from my office in a different organization. And when I was learning Simula, I misunderstood. I thought that Simula was about objects. It wasn't. I found out when I tried using Simula for my purposes, I couldn't use it, because I was concerned with objects. Anyway, so the first two parts, like this about class orientation, is fairly short. And then get what we do about it. It started what have I done about it, but now it is what are we doing about it, because I've been joined. Quite a lot of people are joining me and putting in quite a lot of new ideas and new things. And my dream of this is not that what I'm going to present to you today, the truth. No. My goal is that somebody say, that's a good idea. He's wrong, of course, on that point and that point. I can do it much better. And then we can start building. This is the first attempt. It's not the last, I hope. Depends on several factors, of course. So first, procedure orientation success. My boss, who actually built his first Norwegian computer, we were working, he and I, we were working at Industrial Research Institute, well-funded. Our charter was to bring modern technology to Norwegian industry after the Second World War, when everything had been, development had happened. And so he built this computer, and he was a hardware man, but he realized that it was software that was the key. So we ran around to different industries and asked them, well, I've got this wonderful computer, how can you use it? And they couldn't, of course, because they're well off as they were. But in the shipbuilding industry, it's actually found something useful. So we went around in the different shipbuilding design departments trying to find out what they did and how they were related. He wasn't a shipbuilder, of course. None of us was. So we made this diagram, and the circle is a design operation in a shipyard. And the arrows are dependencies. And he found that something he called the fine table of offsets, which actually is a description of the doubly curved surface or the surface of the ship. But you can see inside there are lots of small pieces as well. So most of the steel in the ship are just plain parts, but quite a lot of them take the shape from the shape of the hull. You want to find volumes, you have to take the shape of the hull into account, and so on. So he made this, he wrote a paper, this is taken from his paper. It's a vision. And he called me in because I had written, I think at least 6 programs. I was the software expert in the team. And so he said, you implement this. And I said, yes, let's do that. So we made a proposal and we got funding. It started in 1960. What does this suggest of an architecture? I mean, I just learned, do not start writing code. That was point 1. Point 2 was, we are not starting a project doing all of this. No way. We were agile, in 60. And we found a corner, the absolute minimum that would make any sense, which actually was a part that detailed design produced material for manufacture, specifications for cutting out all these small parts. So then we needed an architecture which could grow into the whole thing, but where we could start. So obviously, this is obvious, isn't it? A data store in the middle. The data store holds the offset, the hull shape, and a data store where we can, the designers can fill in information, fill in their ship design as things evolve. So as the time goes on, this one will contain the ship designer's vision of what is a ship. Right? Uses mental model in there. I've heard some people say that they developed the world's first database system, and okay. This could be it, depends on how they define it. Very, very important. Well, we had applications around it for the different design operations. And very important, access subroutines. This was assembly initially, it became Fortran. So that an application that needed to access the data store got data presented in a way suitable for that application. And, more importantly, an application that wanted to write in the data store went through the filter of an access routine that protected the data store from malicious data. And then the next was, what do we do with the applications? Then it's behavior, isn't it? Now we have done the first, separation of concern, state, behavior. So now the applications with behavior. The idea of a subroutine came, again in England of course, almost immediately upon this, when I got computers. And they were used for services of various kinds. You know, multiplication, division, trigonometric functions, converting between decimal and binary, which wasn't built in, of course. No, I mean, there were no subroutine library then. And very important for our case, the access routines. And then what do we do with the main program, the main application program? Again, divide and conquer. So we use subroutines for organizing the behavior. And the rule was, actually we used flowcharts for a while, and that's not important. The rule was that a flowchart is one page, no more, never any more than one page. And then you had peepholes down into other subroutines, and you can go down as far as you like. So we had one diagram like a top there, which was the program I'm thinking, the application I'm thinking of, was about 40,000 assembly instructions. Represented correctly, no lying, on a one-page diagram. And I think very easy. I think Jim actually will, Jim Coplin, will, there he is, hello, will say that this is not abstraction. The use of subroutines is not abstraction, it's compression. When I have one call statement here, it's compressing what's down there. Nothing is lost, it's the whole truth, nothing but the truth, and so on. So it's not abstraction, because with abstractions we are removing stuff to simplify. And in the coding we can't and shouldn't do, should never do that. Another thing with this is that if we wondered how this system behaved at runtime, remember this Guardian 4 thing? It's of course just to start reading at the top, find out which subroutine to go into, dive into, read and read. Then later we got, much later in the 60s, Edward Dijkstra wrote a letter to the communications of the ACM, which came to be known as the go-to considered harmful. If you look at those flowcharts there, arrows going all over the place. And by the end of the 60s, it wasn't like that. A subroutine, you started reading at the top and you get down, and that was time. Execution time went down the page. So it's extremely readable, all of it. Where are we? Testing, I think it is. Dijkstra, probably the greatest thinker we've had in our profession. About testing, we didn't believe in testing. Let us say that's right. We didn't believe in testing. We didn't believe that you could test quality into an inferior product. We believed that quality had to be built in right from the start, when you started thinking about something, and then all through. Program testing can be used to show the presence of bugs, but never their absence. We are using testing to prove. I think it was a certain operating system came out with a new version. And there was a one-page thing in the papers, you know. So-and-so is here. It's the most highest quality system ever, operating system ever offered on the market. We found 60,000 bugs during testing. Well, since we know that you only find a certain percentage of the bugs when you test, you can compute how many were left for you to find. But if that said we found 2 bugs during testing of this operating system, then I would really have trusted it. And another one, of course, you have read it already, but I'll read it up because I hate people talking about something else while the text is up. If debugging is the art of removing bugs, then programming must be the art of inserting them. Huh? So, the whole goal of the 60s, when we developed our skills in programming, was get it right the first time. That's lean, I think. Never waste work, so get it right the first time. And with that, I don't mean that we get the functionality right, because it's changing all the time. But we don't waste time debugging. We did test. We did some testing. But we did very, very little testing. All we required was that every statement in the program should have been executed at least once. You can't say that something is tested if you have lines of code there which you have never touched. So that was the minimum. Every statement should be executed at least once. So, what's next? Yes, came again later than the Dijkstra thing about GoTo. It was an article in the Datamation magazine. And I read it. I was just writing a subroutine at the time. And basically it said that it's hard to find bugs in your own code, because when you read it, you know what it's supposed to say, and I read what it's supposed to do and not what it says in the code. Also, it's very great fun to find bugs in your colleagues' programs. Sort of makes you feel good. And of course, when I read somebody else's program, I can learn from it. And maybe I find something that the writer can really learn from. And that sort of brings in a digression that Jerry Weinberg was traveling in the 60s, was traveling around the world giving workshops. We had him several times, teaching us about egoless programming, code reading. He said that you have variables in your program and they are read only. But programs code is write only. Nobody's supposed to read this stuff, is fine. I was actually participating or joining another collaborative open source project. And somebody submitted some code and I actually read it. And then I posted on the email thing, I posted a comment on that code. And the programmer was furious. He was really sore. And when I said, this code to me looked like A, and he said, I think it is B. And I said, no, I still think it looks like A. You're lying, he said, because you know it's B. No discussion at all. Haven't we got any further in 40 years, 50 years? Is that all? Haven't we learned that programs must be read to be checked? Can't we learn from other businesses? You go to these people designing oil platforms, I know some of those, designing the oil production platforms out in the North Sea. There's not a single design document that hasn't got 2 signatures. The creator and the checker. And they refuse to use any method which can't be checked. So they're not using spreadsheets. They can't use spreadsheets because you can't check them. The writer might have changed something, and you can't check. So you can't use spreadsheets. And they are not learning. It's tragic. Get it right the first time. Test to confirm no blunder. Of course, execute every statement at least once. I mean, that's obvious. But to do that, the code must be chunkable. It must be able to. I must be able to take a chunk of code and give it to a colleague and say, read it. I have to go back to my story. Because I had, as I said, I read this article. I had just written a subroutine, 3/4 of a page or something like that. And I ran around the lab asking my colleagues, could you please read this? And I said, no, I'm too busy. No, I'm too busy. They can't. And finally one guy, okay, I'll do it, you know. So he took this. The whole operation was a quarter of an hour. He took it, he read it, he said, ha ha ha, ah, they've got a stupid thing there, haven't you? And the problem was that the program worked very nicely for up to 1,000 data values, and it failed very gracefully for any number of data values above 1,000. And you know what the bug was, really. I would never have found that bug if I tested this program. Of course, it crashed with exactly 1,000 data values. I mean, if you just got a thought, well, obvious from the code. So I would never have found that in testing, because if I'd thought of it, I'd have seen it and fixed it without testing. And if I didn't think of it, I would never hit the number of 1,000. Secondly, he pointed to a few, this was 3/4 page of Fortran. He pointed to fairly high up on the post page. I haven't seen this statement before. Exactly what does that do? So we talked about that for a while. And then he said, a couple of lines from the bottom of the page, you can do this very much neater, don't you know? You just try this. So everything it said in that article materialized on the first test of it. And now you can imagine if I was for peer review after that. It doesn't take any time, almost, and it's very, very effective. So we had the culture and got the culture that the person responsible for the correctness of the code was the reviewer. The writer of the code had no responsibility for the correctness of that code at all. So if there was a bug in it, the writer could say, ha ha ha, I caught you there, didn't I? You know. This one, I think I have to look at the time, because if you take a professor or a parson or some other and lift them up, they'll start talking and they'll talk until you push them down again. But I have to check. Where are we? Agile and in 10:38. See? Yeah. I'm 2 minutes behind schedule. Agile manifesto, I think that's fun, because when all this agile, lean, and ho, these are people who obviously don't know what happened in the Stone Age. Of course we were agile. Of course we didn't have comprehensive documentation, because we wouldn't know what to write anyway. Of course we had customer collaboration, our customers, end-user collaboration over contract. Who could write contract about a vision? Anyway, it was just a question of trust. Yes, get on with it. You have your own money, so it doesn't really matter. We had research funding, so otherwise we would never do it. But end-user collaboration. Of course we had to collaborate with the end users. We were not ship builders. And so actually there were 3 main people we communicated a lot with. The head of the detail design department, which was down there in this figure I had. The guy who was selected to be our first real user. And the operator on the shop floor. And we had it was obvious to us. Whenever we were to meet with our end users, we go to them. We don't call them into our office, because we have got to know how their work conditions, how it is, the smell. And it was important to us to go out down on the shop floor, listen to the noise, the smoke, The smell of burning steel. Have you ever smelled burning steel? It's a very special state. That's how they make, cut out pieces. It's a burn the steel. Let the steel burn in a pattern. We had to talk to the operator because he had several concerns. He knew a lot about how to cut. So we could understand why we had to produce output in a certain way. Because our output should control his machine. And of course we had to talk to the designers. It was about half a day travel at that time to travel right across Norway. But we did it. We had to do it. And they became our friends. All these people became our friends, of course. So we were having crabs and beer in the evening and whatnot. So the point was that we could actually build the user's mental model into the data store. Because we understood how they think. We usually were doing things on a sort of abstract things. We could never design a ship ourselves, but we understood what they were doing. Lean, everybody all together, of course. Of course! Is that an invention? Reduce waste by getting it right the first time? Of course! Obvious. Congratulations, welcome. So, if you don't learn from history, you have to repeat it. So this is actually the first part. And the way we are sort of doing this is, so the next part is I'm going to talk about class orientation and why that doesn't work, and why these poor people in Argo UML have no chance of succeeding, getting it right the first time, I mean. And then into the beginning. What I'm really... But I think it's much easier to talk about what I've done and the new stuff when we had a background of why it's there and what it builds on. And our idea is that, do we have time for that actually? Not much, is it? 10:45 it says?
We're over that already, yeah.
I have to speak much faster.
I didn't do my job.
You didn't, did you?
Sorry.
His job was to stop me when I started talking about the good old days. Shall we take a short discussion? Because what I've done is to say from history. Now I read it here. We need a data-centric architecture to separate data and behavior, to get it clean. If you think of that diagram with the subroutines calling subroutines, there's no way a change in one subroutine could change a subroutine across a way. They were invisible. They had nothing to do with each other. Application design with functional decomposition. Textual code flow reflects process flow. Deichler says that humans are not very good at thinking in time, along the time scale. Things happen. Much better at thinking in terms of space. So if then you read down the code and that is actually the same as execution, you get it. Peer review of code chunks to get it right the first time. The last sort of on this evolution, end of the 60s, beginning of 70s. The last program we wrote in our team was fairly small. It was less than 10,000 photon statements. There were two out of 3 subroutines worked on the first unit test, no bugs. One of them, the remaining one, had minor bugs. No bugs during system testing. That's what we like. That's what we like. Then objects, and it all collapsed. We couldn't do any of it. Shall we start a short discussion at this point, or what?
Yeah, maybe.
Actually,
That's a good idea for a short discussion
Yeah.
here. How many of you are agile? Now you're a little afraid to put up your hand, right? Okay, and when I teach Scrum courses, I tell people Agile is nothing new. It's what we were doing in the 50s and 60s, and then the managers put all this crap on, and kind of what Agile is stripping it all back off. How many of you believe in get it right the first time? It's kind of hard to believe in. If you look at the Scrum framework, how many Scrum people here? So where is testing done in the Scrum framework? No. Now, that's how people do it in software. So I'm not talking about how we do things in software, and that is a good practice. But if I look at the framework, what does the Scrum framework say you do testing? How many of you read the Scrum guide? When does testing take place? It's pretty obvious if you think about it. When you have something to test. And how do you know you have something to test? You're done, 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 right? When does that happen? At the end, with the product owner, right? Is that a no blunder confirmation? Does Scrum use testing to get quality in? No. Okay. How about Trygve said, who's responsible if a bug gets through? Well, ultimately everyone, but in Trygve's experience, I mean, who do you kind of blame and say, ha ha, you didn't catch that bug? Is it the programmer? No. It's the reviewer. So it's the person in charge of the process, right, of reviewing. If the team consistently does not deliver in Scrum, who's accountable? The Scrum Master, not the team. It's the person in charge of the process. You also mentioned something about going to your customers. You use the term, go look and see. What was that context? I don't remember that.
To the designers and the workshop.
Yeah, and this workshop.
Yeah.
How many of you know the Japanese term Genshi Genbutsu? What's that mean? Go see for yourself. So it isn't looking it up in the documents. It's and Trygve said, you know, you don't invite in your customers into the analysis room and have a discussion there. Genshi Genbutsu. Go look and see. Go where they are. So, you know, when Trygve and I first started sparring about this at the conference in Bergen called Roots, about, I don't know, 3 years ago, we started doing the
I think we've been discussing this for ages.
Yeah, I mean, the first time was on the Rudigruten, I think.
Yeah. Yeah.
I finally looked up the date for that. I don't remember now. But
long time ago.
And you were there, too. So I mean, we've been talking about this a long time. And talking about this 3 years ago, we started to talk about this as something called agile architecture. I'm now calling it lean architecture. This is really back to the future. I mean, the agile people in their naivete have lost a lot of the disciplines that are important. How many of you have felt that? How many of you feel a little bit guilty? Okay, well, you know, we've lost this discipline. Yeah, I'm agile. I don't do documentation. You know, it's okay. Any other questions for Trygve or comments?
It was a very different time, of course. I mean, you had you didn't have all these kind of tools and everything, so everything had to be very condensed. And I guess everything had to be, yeah, you really had to think more. I mean, I heard some stories that you would, I mean, with the tools that we have today, and the complexity of the systems and everything, it kind of evolved into this kind of great complexity and a big mess in a sense. And it made good sense at that time to have much more discipline and everything and do it that way. And maybe it was because we suddenly had all this power and tools and everything that we thought that it would all solve it for us in a way. And we kind of lost it. Yeah?
Yeah, I mean, I believe in people and interactions over processes and tools myself. I mean, I think tools have been the problem. I work with Jeff Sutherland in a company called STI. And we're very, very, very against things like Scrumworks because we see people using them and they become a substitute for discipline.
Yeah, I heard two things in your comment, and I think both of them were good. One of them, I got the impression that it was not now hard to think and so on because we had all these tools. I don't think that's what you meant. But the other one was that in those days things were much simpler and now they're very complex. Well, I claim that they're not that complex, but they are complicated. It's made a complexity. But if you get the design right, they can be simple. But you have to have the right tools to think with to make them simple. And we'll do that later today. So I don't really buy all your arguments, but I quite understand them. And that you might even be right. I wouldn't like to admit it, but I mean, you might be right. Okay, class orientation. I was at Xerox PARC at the late 70s. And it was actually Alan Kay at Xerox PARC who invented the term object orientation. And the people there were quite an arrogant lot of people, which wasn't surprising because all they did was new. The PC, everything was new. He'll stop me if I say all that was new. But they said, and I very easily fell in with them being arrogant, they said that there are two approaches to object orientations. One is the East Coast approach, and they said that object orientation is a smart programmer artifact. It's an addition to programming language, just a smart little thing you do. And at the West Coast, it's much more Zen inspired, and say, no, it's much more. It's a new way of thinking. And this is the one which we have lost. Because even the West Coast people, they made Smalltalk, and the way you program Smalltalk is with classes. So they lost the West Coast approach to their own star example. It's only now, these very recent days, that Smalltalk has got object orientation into it. I did it. East Coast approach. Brad Cox gave a talk once saying that there is a small and important difference between procedure orientation and object orientation. With procedure orientation, you have a client who wants to do things with data. The client has to know the type in order to call to trigger the right method or right procedure. Because there are different procedures for different types of data. So typically you have circle delete, group delete, whatever. If that is data is on a draw program with elements like circles and rectangles and lines and groups of elements. While in object orientation, what you do is to move the knowledge about the type from the client to the data itself. So the data has a pointer. Now we call it a class. And then, of course, I can say data delete. And this one will then delete, class, find the method for delete and do it. And if it's that up there, it will find a delete method in class A. And the beauty is that the client no longer need to know the type of the data. They no longer need to know the procedure that will be executed. It's called by intent. So that is the upside. The downside is that the client no longer need to know or can know the method that will be executed. We have now lost, we have talked about it. It's very nice to be able to follow the process through the code. We get to the border of we get to a client that sends message to object, and this line is broken. Polymorphism. That's why Gang of Four say that code doesn't always tell how a system works. Huh? So the exact thing which gives us power is this thing that kills us. And I would postulate that, and also of course at Xerox they said, the object should do the right thing. And if it's clear what is the right thing, then it's perfectly okay. This is abstraction, because we have no longer link into what it is. No longer the whole truth, but part of it. But what if you are, and that's fine if you're programming in the small. And it worked very nicely for many years with programs in small. But it breaks completely down for programming in the large. When the right thing depends on context. And the whole thing. Because you assume that you just put together some object and they'll collaborate properly. No control of how they collaborate, because you don't need to do that, because they do the right thing. So that's where we got into trouble. So I'll draw it like this. No. What's happened? 2, I think. Yeah. No, all right, I'll put that in, that's right. Ah, it's alive. So this is the situation in class-oriented programming. And I'm still just thinking in terms of objects, because, but these objects, of course, are instances of classes. Then, when this system or this collection of objects is asked to do something, a use case, then a message is sent to one object. That object executes a method, sends a message to another object. This is actually the network of communicating objects that the Gang of Four was talking about. There's another one. Different ones depending on what to do. There's a third one. This is a bit interesting because next time I execute exactly the same operation, this happens. First time I used that object, and now I'm using this one, because we don't always use the same. But it's dynamic. The network of communicating objects changes from time to time. Now, of course, when we program the classes for these objects, they don't know about the lines. The class tells us everything about what an object does when it receives a message, but it doesn't tell us anything about where it came from or why it came. So this is what we've got. This is what we're left with. So the class of this object has to implement both these two methods. And this one, these two, and so on. And you pile on a few and you see what happens. And the class code gets cluttered with a lot of small fragments of interaction. I can't send this class out to be reviewed, because it's only part of the truth, and it's part of several truths, different parts. If the execution of a use case is spaghetti code, then this is noodles. All we are left with is a bowl of noodles. Now, please review. You can't do it. So what is happening is we have an end user up there. The end user has a mental model of what it's doing, and the program probably implements that in its data part. And the end user has use cases or operations, or call it whatever you like, and they trigger object interaction. Then there is a chasm. It's a deep chasm. No connection. And then they have a programmer with a mental model. A programmer thinking in terms of classes and attributes and methods and writing code. But we're just seeing there's no connection up there in anybody's mind. I know that it's not quite as bad as that, because we are not doing object-oriented programming, as Brad Cook says, because he said that the client should not know the method to be called, but of course today we type. So the client has to know the type, and if you type on class, and we know quite a lot about what will be executed, apart from that polymorphism makes it possibly that we don't know anyway. And also, of course, a programmer who's, let me be personal, it's much easier, because then I can talk down on me. Now, suppose I'm writing, but I was actually all through the 80s working with many other people on a very large program. And it was perfectly structured. There was no problem. I mean, you could go in anywhere and understand exactly what was happening. But now, 10 years later, I thought I should go into that program and pick up something which I knew was solved very neatly there. I couldn't read a thing. It was completely opaque, because I'd forgotten all the things that was in my head. We actually noticed it at the time when we got a new programmer in. It was very tough for him to get into this program, because everything, the whole design and everything was in our heads, not in the code. Okay. So that is the end of class orientation. That's all I want to say about it. You all know about it. And this one, the discussion should have finished 5 minutes ago. I had a suspicion this was going to happen. Class orientation. Let's try the same things again. Separation of state and behavior. Now state and behavior is mixed into the object. That's the whole point of object orientation. So the class defines the state and the behavior of the object. System design with functional fragmentation instead of functional decomposition. Because there was a university, unnamed university professor, he said, why can't we have calling trees in Java? That's a good question. I'm not going to answer it here, but it's a good question. We can't have calling trees in Java because the code is fragmented. There is no clear path from a call to an execution. No chunks. There's nothing in this, my object-oriented, that is class-oriented program. I can tear off a page and give to a colleague. They ain't there. So I can't do code review. So I have to rely on testing, which is a broken read anyway. It's bad, isn't it? Coop, do you want to have discussion now, or shall we just move on?
Been sitting for a while. Do people want a break?
No, that's not break time yet. It's about two. I thought before break, anyway, that I should take two slides into the next and the real stuff. You see?
Okay. So does that sound good to people? A couple of slides, and then, but I think it is break time.
Yeah.
The moderator's been pointing it out. Okay, so take a couple more slides, and then maybe we take a break. Sound good? Okay.
Okay.
Object orientation. And the East Coast approach, an object encapsulates state and behavior. It receives messages and does something, and that's about it. There's no link from one object to another. Object orientation. An object receives messages and sends messages. For every message passed, there is a sender and a receiver. The essence of object orientation is that objects collaborate to do some task, to serve some task. The most important things about an object system happens in the space between the objects. And it's probably a good idea to think in terms of black box objects. We don't want to know what happens inside, we want to know what happens in the space between them. So, to sum that one up, an object by itself is not interesting. The essence of object orientation is that objects communicate to achieve a common goal. So we need to augment our code with explicit code that specifies exactly these networks of communicating objects and how they communicate. That's what's missing. We've got to have it in order to understand what happens at runtime. And the next is a demo, an animation of what we're talking about. And that we could start with after break. Okay?
How long is the break?
Well, I think, I suppose by your time scale, it should be finished about now.
The time is
11:20 is where we should stop.
11:10 right now. Could we have a shorter break for 11:20? And we'll be back here again at 11:20 and continue the talk again. So, now it's time for the second part of this session. And I did forget to mention James Coplin also as collaborating with Trygve here in the question and answering sections. So, Trygve, just
Thank
continue.
you.
Thanks.
Thank you all for being back precisely, because I need the time I've got. The Gang of Four was talking about networks of communicating objects. And it's easy to read about it. I thought it would be a good idea actually to see what they're talking about. So I wrote an animation program. This is, by the way, is not PowerPoint, it's a program. And so in this area, this is the universe. Stars and circles are objects. Where is it? There we are. So I say animate shapes. And shapes, that is, objects come and go in a universe of objects. So that's the first part. Sometimes there are stars, sometimes there are circles, that is that instances, different classes. And this goes on. But then we try and give it some behavior. So I start another use case. And now an arrow means that one object sends a message to another object. And we watch this for a while, and we can see quite easily there's a pattern here, something repeating. So this, the red path, is a network of communicating objects. How do we describe it? Is the question now. We need somehow to catch what's the essence of what we see and what is just something that happens. And the first attempt, we know that every object has identity. So the first attempt is to get it down there. We look at the identity of the object that receives a message according to this animation. So we get a list, I can promise you, of random numbers. You'll see later why, that's how it's designed, so they're random numbers. But what about class? Class is wonderful. So let's look at the class and see if we can find a pattern. And again, I can promise you, you won't find it. Class is completely irrelevant to what is happening here. We are just sending message from a shape to a shape, and what the shape is, I don't care. The system doesn't care. So the next then is, what if we name the objects we hit? What if we sort of name the first, second, the third, fourth, fifth? First, second, fourth, fifth. Let's try that. Roll 3, 4, 5, 1, 2, 3, 4. Can you guess what's coming? We call them roles. The position in the network of communicating objects is the role the object plays in the context of this particular pattern. So I want to stop it, because now we have seen what I'm talking about. So roles, interactions. So I want to go back to what the president, this one. I want to go back to so let's see what we have done. This is the old picture we had a little while ago. So what do we do now to clean up the mess? What we do is to extract the interaction. We extract the communicating objects into a separate, distinct structure, orthogonal on the class structure. So we have an additional structure that can help us master the complexity and close the gap between compile time and runtime. Simple, isn't it? And quite beautiful. Now, each of these circles is, I think I'll do the next. Then we package the roles into what we call context, because we want to bound the whole thing. So the context receives a message from the environment, triggers the behavior of the first role, because the roles have behavior, which sends a message to another. You know where the name role comes from in the theater, you know. It's from old medieval theater. The actors got a roll of paper or parchment or something. So an actor came on the stage saying, "Oh, Julia," you know, and then Juliet, you know, "Oh, Romeo," you know. That's how it is. And that's what we're doing. It's as simple as that. Each role has a role, like this. So it knows what to do. Romeo and Juliet, they communicate. Our roles communicate by sending messages to each other. That's it. And somebody say this is complex. Very simple. But it gives immense power, because now we have power over the interaction, over the runtime. Let's do this a bit more carefully. I have to learn that it doesn't help you that I point on my screen. So let's say, thank you to Jim for this example, that we have an automatic teller machine, and somebody comes along, "I want to transfer money from one account to another." So they go up to the teller machine, and which leads to a message being sent to a particular context. It's instantiated, and then a message. It first gets its date, the account numbers, and then the trigger saying transfer 500 money. So what does the context do? I have to get this right. Several things. First of all, it knows what the roles are, so it has decided, I have a role called the source account. I put a cross on the stage, that's there. And I have a destination account, put a cross, that's there. So it's all it is, the roles are at the moment, is a cross on the stage. And then the next thing it has to do is to find an object to play that role. Casting is called in the theater. So it goes through all the possible and says, "Hey, you play this role," and put it on the cross for the source account. And then injects the code into that object saying, "This is what we are going to do." And I do the same with the destination account. Then the last step, what the context has to do is to kick the thing starting, telling the source account, transfer 500 money. And the source account looks at its role. First I'll do, I have to check that I have got 500 money in my balance. Check that, that's okay. This should be in a transaction, I think, so we start a transaction. Then it deducts. A banker will always deduct before they add something. Something might go wrong and they could lose money. So we deduct 500 money from my balance. I send a message to the other one. Get the message. Yes, I can add 500 to my balance. Return, this is okay. End transaction, end job. Now we do have code. For every step, there's no bridge. Why does this work? Because we have put on actually what I did now was to put on a very strict restriction on object-oriented programming. Because I said to the source account, do this independent of your class. So I have blocked what is it? What is the word I'm looking for? I blocked the ability to have different methods for the same message. Polymorphism. Why didn't you tell me? It's so simple. That's one of the fun things with getting old. Words, play hide and seek up in your head. Beep, beep. Yeah, you don't find me. So anyway, there's no polymorphism when programming in the large, which we're doing now. We leave that for programming in the small because there it worked fine, but we cannot permit it when we get up to this level of complexity we're talking about now. That's why we get control. So, DCI, that's the name of the paradigm, data, context, interaction. We had a little while ago, and they have the same again. We have the end user mental model, implement that as data classes. But now, these classes are quite simple because we pulled out all the dirty stuff. And a pure programming in small, you can say that only state, but I mean, you can add more stuff too, but that's not important. So the end user's mental model is reflected in the data model, which is implemented as some classes. Simple classes. That can be checked. Then for each use case, there is a separate context that we can write. And at that time, we look at the roles and the role methods that we give to the object playing the roles. So we get the so we have data, implementation of the user's mental model, context, organizes the participants in performing a use case, muster the objects, inject role methods, trigger the interaction, and then the interaction itself is what happens at runtime. So how I have implemented, and I used a dialect of Smalltalk because Smalltalk will not block me from doing anything stupid or clever, whatever. No bounds, no static typing. It's very, very open. And then the D part is implemented, as I said. I mean, in my head, there might be a conceptual schema, and somebody might like actually to have it on paper. I don't know. But the mental model is realized by classes, their attributes, and local methods. Local could be derived attributes, for example. If I have the birthday of in a person object, I can have age because it's computed, that kind of stuff. That's the data part. And the classes are instantiated and get into runtime objects. So on the other side, the doing, use case, whatever. There's an environment. In the example, I had the teller machine that instantiates the context. So there is a context for each use case, and the context is responsible for a set of roles. So it's there it's able to say for any use case, what are the objects, exemplified by crosses on the floor, by the roles, how are they interlinked. And then at runtime, these roles are bound to objects, and the objects know how to do and have the interaction going. The question now is how to inject. And in Smalltalk, all I can do is that when a role is defined with a role method, let's see, this one, it injects those methods into all classes that provide objects for my interaction. And this is done automatically, and behind this scene, that's another demo. This stuff is being implemented in many different languages at the moment. C++, Ruby, Python, Scala, Java. You will be talking about C++ and mainly Ruby, and you'll be talking about Java after lunch. So you can see how it's done. I think, for me, some programmers enjoy text files. The longer the better. And they have the brain that can deal with it. I haven't the brain that can deal with it, so I do not enjoy them. So I prefer to have tools. And now I'd like to show you the tool, how this animation program is actually programmed. This is what I'm talking about, is the code. It's no artist impression or anything like that. So, where are you? There we are. This is what I call the Baby IDE 1, because it's the first version. An integrated development environment for DCI kind of programs. The one idea is that I see the program from several perspectives. Each perspective, I see some things and hide other things, so I can concentrate on one thing at a time. For example, I can see the data classes, I can see the context classes, I can see the interaction itself. And now I'm looking at the interaction, and that's all I want to bother with you today. We remember that the context received a trigger about to start it. And it turns up here as a role. And it says, so I start with animate roles. I say that as long as my state is something, this is what I do. So I remove all arrows from the screen. I reselect objects for the roles, so I get a new set of objects, and then I kick off the first shape to do its work. This is a role method. I click the shape 1. What it does when it receives a message is it displays itself with a 1. You saw that one, a big 1. And it sends a message to the next, and it's doing that a bit roundabout way because I want it to display itself. So that's the one thing. Another thing is, how do I select? So I just hover over it. How do I select an object for shape 2? And that's a method saying shape 2, return data and a shape. So that's also I could guarantee randomness because it is selected on random. So this is a kind of, in this perspective, I see all the roles. I see how they are connected, that is the communication path. So I see the networks, possible networks of communicating objects. I see the role manuscript, that is the role method, what the role does. And of course, a role can respond to several messages. So I've got the whole behavior in one view. I don't have to, when you have red and blue and green methods in the class, how do you know which one is which, and how do you know that the program hasn't done something smart and made them dependent on each other or whatever? So this is the tool. And my hope is that somebody will actually make tools for other languages. Because with this tool, what I see here could actually be very close to my, as a programmer, mental model. Just look at the code down here. This is actually what I would do. I say shape 2. So shape 2 is a variable. It means the object currently playing the role of shape 2. I mean, I can't say that every time, can I? So I say shape, it is shape, send a message to shape 2. In order to do that, because there must be stuff behind the scenes, in order to do that, of course, I had to hack the compiler, so that the compiler understood role names. And the debugger should understand role names. I could do that in Smalltalk because the compiler is a class in the class library, so I can subclass it. It's no problem. I can't do that in Java, can I? So this is the tool. This is what I'm doing. And what this takes, what is the time now? It's about 11:50. Wonderful. You can see this, or some similar kind of IDE, should support the programmer's mental model of what is the program. And first that we haven't got with ordinary class. You edit with the class NetBeans, for example. Each class is a text file, possibly organized alphabetically on the methods. There's only one thing which is certain. I'm never interested in seeing the class in that perspective. And how do I know which methods belong to this behavior and this method belongs to that behavior? And this is just a support thing. This is a convenience method. And this is all the noise. How do I know? It's all mixed together. And here I pull it out, view it, and work on it. And this can be reviewed. I say self display large. What's self? Self is the object that is currently playing this role. So a role in that sense is an interface, a requirement to any object. Any object satisfying my interface can play this role. And that's another other chunks which can be audited, but separate from this one. Let me see now. Which one shall I do, I wonder? I think I'll do that one. Didn't it, did I? Let's take that one. Some people believe that if you write your programs in C, you are procedure-oriented. If you write your programs in C++, you are object-oriented. Nonsense. The difference between being object-oriented in one's mind and procedure-oriented is very simple. If I'm procedure-oriented, I can say, this happens, that happens, this, then this, and then this, and then this happens. Something happens. If I am object-oriented, the actor, the one active part, is never neutral. So I say, A does this, and then B does that, and then C does that. It's always a question, who does it? You have to add to what happens, you have to add who does it. If your mind works that way, your mind is object-oriented. If you don't think about who does it, your mind is not object-oriented. And you can use C++ or Java or whatever. It doesn't help. So, I think that... Oh, shut up. Sorry. We did that, we did that. So now, this figure where we had the gap, the chasm between runtime and compile time. Now it's closed. The compile time, and we instantiate the data classes to get the runtime objects. That's open, clear, that closes the gap. And the context is instantiated, selects objects to play roles, and triggers the interaction. So the gap is closed. Isn't that what we wanted? No, it's what I wanted. Anyway. So we summarize one. In 1970, we had data-centric architecture, separation, state, and behavior. Now we have a DCI separation of system state and system behavior. System state in the data classes, system behavior in the context classes. Separated out on each behavior. In 1970, we had application design with functional decomposition. Now we have this decomposition on roles. And we see exactly how they collaborate and which role. And this, incidentally, is responsibility-driven design. We have the objects, the roles, they divide the work between them. The whole context is responsible for doing something, chops up the responsibility into sub-responsibilities and allocate it to the roles. Responsibility-driven design. That's what it is. We are there, to put it that way. We had textual flow reflects process flow. Well, we haven't quite got that, have we? Because we haven't got something we can read down. We have actually, and that may mean that the IDE I showed you isn't quite finished. That we have to go further to get the full linear code. Maybe not. Because at the moment we can look at the role methods and see how they fit together. And if we follow reasonable rules, then we have, let's say, 7 plus minus 2 roles, nothing more. If we start getting 50 roles, then we are splitting this up so you don't have to see that many because it's too much for my head, and you might end up with 50, fine. Not fine, because somebody reading your code might not be able to follow 50, so you should keep it down. What was next? Yes, the methods with roles show the process flow, but we have to sort of read these methods in a sensible way. Peer review is now possible. It is meaningful to review a class. It is meaningful to review a context. And we can get it right the first time. And now, testing can be a confirmation of no blunders. No industry, whatever, has ever been able to test quality into an inferior product. Can't be done. And that was my last. So now Jim was going to start the discussion. So this was much shorter than planned, and that's fine, isn't it? We have now, depending on how hungry you are, should have plenty of time for discussion. When are we supposed to finish? I'll look it up.
So how many of you have invented this already?
We have 20 minutes, actually.
So how are you doing this? What language are you doing this in?
I think I have to disappoint you a little bit, because I think that these observations, this kind of thinking is well known for the developers, not all, and it's used by the developers, or the developers try to use it, even if they didn't know it. I think I agree with all of that stuff, but we've all forgotten some way, somehow, to think about the objects in that way. But even I used to look at the hundreds, thousands lines of code that developers write. I write within Cell, and most of this code is tried to be written in this way, actually. So we are creating the roles, abstract them. We are really uses we rarely use polymorphism actually in a real code. So it happens, and I am truly glad that it's been discussed here right now. So that's the point.
Okay, that's great. Now we'll go into some more pieces of this later this afternoon. This is more than just having roles, because there's this issue of injecting the roles into an object, and there's this issue of roles executing in a context, and this dynamic mapping that goes on.
But if you classic languages, it's impossible to do it so Konya. That's why I'm saying that we are trying to do it.
So people interface.
Yeah, but this is more than just using interfaces. So interfaces are a good start.
If they define a role, then you can have the ambiguity of something that satisfies it, and you can inject it or whatever you make that. So that's part of it.
Yeah, that's a very big part of it. Another part of it is how the roles work together. So this is concept of a context that brings the roles together. The other is who makes the decisions about the mappings of the roles to the objects that are playing those roles. That's also something done by the context. No, you're right. I mean, people will say this looks like Spring, this looks like aspects, this looks like AOP, and they're all partly right. But every one of those misses a little bit. And so what we've seen is that people have been edging up on this for the past 5 or 10 years. I mean, Scala has roles as full first-class concepts. And so, I mean, Scala looks like it was made for this. But it's not DCI. There's a few more pieces yet that have to do with the dynamics. So there's a lot of pieces of this that we've been converging on. There's something going on.
I have a question. If there's one row falling into another row, how will you then get this overall view of this linear picture of what's happening in the program?
Right, and that's the last thing you mentioned about the environment, is that one of the improvements we can add to the environment is getting the overall view of the algorithm, right?
Yep.
And that's a tool and environment issue. But it's intractable with objects because of polymorphism today. With roles, you can do it.
Was that quite the question? Did that answer your question? I got a feeling it was different.
If one row is falling into another row, how will you get this overall view of
Did you see folding into, or what is it? One role is...
Invoking a method of another role.
Yeah.
You see it in the code. It can only be done in the role
I
method.
mean, there's one row, and then in that row you see call row 2.
Yeah.
And if
Yeah.
you look at that,
Yeah,
that's
yeah,
as far as you go. And then you need this
Yeah,
overview.
then you got it. Then your answer was, yeah, that's what we don't know how to do yet. So all we've managed to do is to squeeze the actual code needed to understand it. But we haven't got to the point where we can say we do this, and this.
Maybe some static analysis.
No, it can't be done statically.
Well, not in Smalltalk.
Well, we can't do it anywhere else if we can't do it in Smalltalk.
But there's another aspect.
That's interesting.
There's another aspect of this that's important. And that does anyone here do cognitive modeling? Or looks at the psychology of programming, because there's this notion of chunking, and we can only deal with chunks that are so big at a time. So even if you can view the whole thing, it doesn't help, because your brain isn't that big. And so you need a form of whole thrusting.
One use case. It would help
Yeah,
with one use case,
yeah.
for example. So
Yes.
I don't know if you read Ivar Jakobsson's book on AOP, because
No.
there they have this concept of a use case as an aspect, and so that the aspect encapsulates the entire use case. I don't know if it's a good idea, but it's
Yeah,
interesting.
no, I haven't read it, but what I've seen of aspects is that you inject code into several classes, but there is no collaboration. So, but I can't discuss that because I don't know.
That's quite possible. Yeah.
Yeah,
But when I started this, where is the fortran of object-oriented programming? Even simpler, where is the assembly language of object-oriented programming? That's what you're asking for. Where is the assembly language where we say, this happens, this happens, this happens, then either this happens or this happens, and then meet again, and we go in a loop. And
Yeah, I mean, one could imagine perhaps one place in the program that you designate to
Yeah.
be sort of overall description of the use case or this particular process that lays out this role.
But so I wrote a book on that called Multi-Paradigm Design. And here's one place where I said, you have the ordering of steps as a procedure. And then they will invoke the primitive methods on objects necessary to do what you want to do. The problem with that is that it's the wrong pattern of cohesion. And that, in general, that procedure needs very detailed access in understanding those objects, not just interacting with them through their interface. Because if that procedure is interacting with the objects through their interfaces, then the interfaces get really clumsy, and you have a lot of getters and setters. What you want to do is inject parts of the algorithm into the objects, not having a centralized algorithm that reaches out to the objects and asks them to do things. And that's what makes DCI different.
Yeah, but
and so you need to balance the centralization and distribution, and it's a fine balance.
Local reasoning and what's other thing called?
And so we've got the local part down, and now the question is, how do you represent the global part? And Trygve has done it here to some degree with the tool, where you can look at the interactions between the roles. And maybe there's a better textual representation. I don't know. There's a lot of good research to be done here. But it's not like, okay, here's a big stupid hole and it's obvious. I mean, this is really, 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 really subtle. But there is a lot of good work to be done here.
Is it fair to say that certain programming languages are not suited to modeling roles? Because you mentioned something about multi-paradigm languages, and some languages are multi-paradigm, some aren't. So I'm trying to translate all these role concepts into programming concepts, and it just seems that certain languages are just better suited. Thank you.
Yeah, I think that's true. One thing you might talk about, Trygve, is that one of the goals here of DCI is to make the code understandable. And Trygve talked about that indirectly by saying we can't do code inspections anymore, we need to do testing. But the goal is to be able to read the code and understand well enough what's going on that you have a higher degree of confidence about it working. And that is certainly sensitive to language, environments, tools, things that give you insight into the code.
Yeah. Do you want me to say any more? Didn't you say it? Or did you say, Trygve, you should say blah, blah, blah.
Do you have anything to add? I mean, you usually have such a good way of saying
but
this.
Okay, let's put it because the question is, from what I said, no problem doing this in Java or what you like. And the reason there is a problem is what I didn't talk about, the infrastructure below the IDE I showed you. And that infrastructure has to do with dynamic binding of role names to objects. It has to do with cooking the compiler so that it understands what I'm talking about when I talk about a role. And the compiler actually inlines the code needed to look up the dynamic, what is it? Dynamic
Binding?
It's a dictionary at runtime binding role names to objects. And the compiler inlines finding that dictionary, which isn't trivial, and then looking it up. And all this is below. And why I don't like C++ and other implementation is that the programmer has to know about this. And the programmer shouldn't need to know about that.
By the way, there's another important clarification. It gets back to what Rebecca said. Where Rebecca said, well, you program in interfaces, right, in Java, okay? And we call those roles. That isn't what is meant by role here. A role is something that has a script. So a role has methods. And they're generic methods. And they will become typeful when they are injected into an object of a specific class that has a specific type, or in an object that has a certain type. So you can't do this naively in Java. That's why you need an environment like Chief or J that Richard is going to talk about this afternoon, because roles can't have methods in Java. Here, the roles have methods. Traits are a technique that you can use to implement this. Yes, 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 yes. And that's kind of how Scala does it. Scala has traits as a full first-class language thing, and now you just inject those roles into an object. You say, new savings account with money source, and poof, you have an object that mixes all those behaviors together, and yet the source code is separate. Right, and again, aspect J handles that part of it, but not the context part, not the interaction part. Okay, and so there's, as I say, there's been people who've gotten different parts of the elephant over the past 5 years, right? And the thing that really pulled it together was when Trygve said, okay, traits in fact were the trick in Smalltalk that kind of caused this whole thing to collapse in on itself so it was expressive and actually allowed it to work. And that just happened 6 months ago?
No, probably get closer to a year.
Okay, whatever it was.
Yeah, but the way actually it's done, the injection is done, I believe, with aspect-oriented programming, is something called weaving. You weave the code into the code and you have to compile the whole other thing. Yeah. What we do here is a class has a dictionary binding message names to methods. Yeah, right? In Stock, that dictionary is visible to the programmer. So what traits does is I compile a trait into bytecode as a method, and then trait system goes into all the classes I've listed and just put that into the dictionaries. It's not a copy. They just put the same method into the dictionaries, operate upon the message dictionaries. So you see, there are lots of stuff going on behind the scenes which have to be rethought. And another thing, the context is created, instantiated, when we start on an operation, use case, sorry. And when that use case is finished, then we don't need it anymore. So, in my implementation, the context lives on a stack. Can you do that in Java, I wonder?
Yeah. Aspects can do certain things.
Yeah. But it's no, as we have no reason for competition here. Because these are ideas. If somebody can use them in a different context, wonderful. I mean, there's no one way to salvation here.
Yeah. You could, for example, start a context, and at that point in time, an aspect is instantiated that then uses the roles
that
and injects those into the object.
Yeah.
Okay, let me talk about this in another way. We can say that in some of our implementations, we are using aspects to do 20% of this, and then there's 80% left. So yes, you're right, aspects are the solution for 20% of the problem. Now there's 80% of other things we need to do in terms of taking care for the context, for example. So if it makes it easier for you to understand that we call them aspects, let's call them aspects. No problem. Aspects are a technique. Well, I don't either. but
Jim?
Yeah.
This one here. This one was first. This was first, I think.
Okay. Regardless of the language, we have actually another problem, as I see it, is when we're communicating between processes. Because in larger systems, you divide them into several bits and parts that run in different running environments. So, I mean, the context should be applied there as well.
Yeah, it's...
so, regardless of the language, you have that problem anyway.
It's, yeah, and it's... I have only worked with sequential programming. Yeah. And I know there's an open field, and doctor students are welcome to study it, because there's lots and lots of work and interesting work that can be done there. Well, but the principle, I think, should survive.
There's a guy in the Netherlands named Serge Beaumont who has some pretty good inklings on how you might attack this in a multi-thread environment, and it's essentially the run to completion task solution. But he's been looking at that a little bit. I just got mail from him this morning, by the way.
What's wrong with Beetle? That wasn't yours. but anyway, I mean, it is in some way, what we're trying to do here, if I understand it correctly, is for some to solve a process, something running that you can actually read from up down, and that may involve several systems, and there are other techniques, good or bad, in doing that. For example.
Well, probably not several systems, because the scope of deliberation here is a use case.
Okay, yeah, one system, but several different processes.
No. A process is a unit of scheduling. And you don't worry about units of scheduling within a use case. You're confusing object. I mean, a lot of people think of objects in terms of processes. They're not. They are not units of scheduling. Okay? A process is a unit of scheduling. It's a unit of time. Here we're viewing time as sequential. And the question is, how do you deal with non-sequential formalisms? How do you formalize something that is non-deterministic? That's a whole other can of worms.
I don't know. I think we're using the wrong words here. When I mean process, I mean a computer, a business. No, I think you mean a business process, and yes, you're right. What I mean when you actually have to divide it into two different machines, for example.
That's what I mean, a unit of scheduling. They have two different program counters that are in different timelines. How do I talk about a single deterministic scenario involving multiple timelines? I mean, that's a completely different area of research than this. That is not the problem we're trying to solve.
Jim, should I have one more, because it's actually we have managed to spend the time.
I was just thinking of the Matrix movie, where you actually have this person, and he goes into this context, and he loads this module into himself, and then, wow, suddenly he can do like Kung Fu or whatever. Then he goes some other place, and he wants to eat breakfast, and he loads this module that he can eat breakfast. And that's exactly the kind of idea that you run time, you load this module you need for the specific context you're in, and then you perform the role.
It's perfect!
Just watch the movie.
I never thought of that. That's great.
But they already solved it in the Matrix.
Show me the code.
It would be a real problem if humans were statically typed.
No kidding.
And that's the problem with these statically typed languages, that you really need a dynamic language where you can runtime, like change the code and load the modules that you need at the specific time.
Well, yes and no. And I'll talk a little bit about that in my talk this afternoon about how you do this in C++. Because the universe in which you're working allows you to dynamically choose different views, like that. But the views can be preordained, and that gives you a higher degree of static analysis and certainty. Some people need that, some people don't. It's an engineering decision. That's not part of DCI. It is a way of implementing DCI. How are we on time? We're out?
2 minutes.
2 minutes? You were on the queue here.
Yes, I've just got an input concerning this discussion about the aspect J and aspect something. I think it's that we've been using the hammer to create the way of thinking, for a couple of years. So we have the class object or something oriented language. I think that we don't need to classify languages in such a way, because it's a thinking that is object oriented or driven by something. And then we have a hammer, then we have a language. That's why we cannot switch our thinking to object oriented, and we are still class oriented, because most of us are working with the class oriented or class specific languages right now.
Yeah, that's Whorf, right? Language shapes what we can think about and how we can reason, the Whorfian hypothesis. And there's a lot of that going on, is that we don't have any object-oriented programming languages. The closest was probably Self. And, well, Dave got a lot closer than most people do. But even at the bottom, it has things that he doesn't call classes, but they are.
The one thing is that we are building this thinking, and then we are argumenting the thinking by the language. Again, it cannot be different, because it's Java, it goes like this. In Aspect J, it goes like this. So it's very hard to change the thinking, because we have strong arguments, the language, that we're building the thinking upon.
Yeah. Actually, I think that's very important. If you try to think of DCI in terms of your programming language, you're only going to get a small increment towards enlightenment, towards really understanding this, you know, and kind of getting the big picture. It's this conceptual model. This is exactly what Trygve said. You're right. People are doing East Coast thinking. And what you just described is East Coast thinking. To really grasp DCI, you have to do West Coast thinking and then bring it back to the East Coast and said, code really matters.
So,